So that was cloud apps, right? So number one of the things that's driving this whole movement of SD-WAN, there's more apps that are going to the cloud or becoming hybrid. The second one we're going to get into in some big detail is this one around video and driving this insatiable appetite for bandwidth consumption within enterprises today. And we're going to answer an interesting question which is, what does video, a web proxy, and hybrid WAN path selection all have in common? And Shashi Murugu is our technical director from the Steelhead R&D group, and he's going to take us through this conversation.
Hi, my name is Shashi Murugu, and I'm a technical director in the Steelhead. Is your mic on? Yeah. Is it on now? Is anybody getting any copy? Or great. Is it on now? Yeah. Okay. All right. So my name is Shashidhar Merugu. I'm a technical director in the Steelhead business unit. And thanks, Josh. So I'm going to build on top of what Scott and Kenny showed you and what Josh talked about earlier. So let me first talk about when we say that we focus on applications and when we say that we care about application performance and application intelligence, let me talk about what we mean by going one step deeper into that. And I'll come back to that question that Josh alluded to. So now if you look at the application, the protocol stack, traditional applications typically used to be built on top of TCP. They were on top of IP and maybe a data and physical link. This used to be the classic multi-layer protocol stack for traditional applications. Think about file system applications or emails and all of that. But modern applications these days are built on top of HTTP, and that rides mostly on SSL, and this over TCP and IP and data and physical layer. So this is how a modern application would look like. And in this world, these three layers that I'm highlighting here, this is the new transport. And if you think of any application, any cloud-based application, for example, Office 365 or Box or ServiceNow, almost all of them are built this way. Even on-prem applications, let's say SharePoint or Exchange, they're also built this way. So this is the new modern stack that you will see in applications. And when we say our Riverbed products help improve application performance, what we mean by this is we really understand applications at this layer. And the way we understand that is because of our strength at these layers. And I'll get into a little bit about our strengths in intercepting at the TCP layer and how that enables us to do these deeper and more intelligent things. But let me first talk a little bit about SSL. Now this is one of the challenges of these applications, that almost all of them are encrypted. If you look at all the SaaS applications that are typically used in enterprise, they are almost always encrypted with SSL. And we at Riverbed have come up with solutions to intercept at this SSL layer. Our solutions are based on proxy certificates, but the key challenge here is that you need to keep the private keys that you're using to intercept these SSL sessions in a secure place. Typically, we keep them in our data center location. These private keys are not on the branch location. But yet, the branch device that is closer to the client is the one that actually needs to decrypt the traffic. So that is the problem that we have solved at Riverbed, and we have patents around our solution. Our solution is something that we have presented, and it's actually in production, in use at many enterprises. including the top financial firms, including customers who are really security conscious, federal agencies, for example. So our solution, the way we have built it, is trusted and is in production for more than about 8 years now. And we are constantly innovating in this area because we truly believe that you have to get to this layer to provide any intelligence that is at this higher layer. And this is where all the smart things happen. And if we have to provide business value to an enterprise, we have to operate at this layer. And the way we get there is only this way. So we have been innovating in this space, and we have been constantly keeping up with all the things that happen in this SSL and SSL space. We have recently introduced a certificate authority on our products. We also have introduced a solution that works with hardware security modules, where you can actually store your private keys on your tamper-resistant hardware security modules that a customer may have. So this is our strength here. And as you have seen in Kenny's demo, you have seen the proxy certificates that we have used for Box, and these are typically created by an authority, and then that authority is trusted by the enterprise users. And that's how we become this trusted man in the middle to be able to do all the magic that you have seen that Kenny demonstrate. So now, let me, before I go back to TCP, let me go into the higher layers here on HTTP and application. And let me dive into one particular application, that is video, and talk a little bit about what we do at this layer and what we do by understanding.
Before you get into that, on the SSL component, so your box becomes a certificate proxy, is how you described it, a certificate authority even that can present himself as an authority in the chain to the ultimate client that's consuming that data?
So we have multiple options. Most large enterprises may already have an authority of their own. So in that case, we get the authority that an enterprise already has to sign the certificates that are deployed on the Riverbed boxes. So the users of an employee, the employees of that organization may already trust that existing certificate authority that the enterprise may already have. So the enterprise, the enterprise team, IT team, will actually sign the certificates for us to be deployed on the Steelhead or on the Riverbed solutions.
This is a little different from the Steelhead flavor of this that I remember deploying, where I had to install a certificate on the Steelhead so it could decrypt the data stream, optimize it, re-encrypt it, and then send it on its way. This sounds like now the Steelhead is actually in the middle of the certificate exchange. There's really two different conversations that are going on. So
but if you're talking about a third party like Box.com, the only way you can get a private key for that is to install your own generated certificate and your own private key. So basically, you're lying.
It's a man in the middle.
But if you already accept all your corporate certification authority, you'll believe you've connected to Box.com.
Yeah.
For your internal stuff, you can just throw your own certificates
you're really,
on there.
the client's really terminating his certificate connection on the Steelhead.
Yes.
Yes.
Yeah.
Which, I mean, a lot of modern UTM devices and firewalls do that anyway for SSL inspection, right?
Yes, and SSL proxying with inspection, same deal.
But let me point out one difference, though. Let me point out the difference between how, let's say, a legacy SSL a load balancer, for example, would do. So the place where you have the private key for that certificate is where you actually intercept the SSL session. But in our case, enterprises were not comfortable with putting a private key at their branch location, which could be insecure. So what we have come up with is an innovative way where you have the private key still in your data center product, but we have a way to securely transport only the session key that is just valid for that session over to the place where it needs to decrypt the traffic. That's the innovation of Riverbed. Does that make sense?
And what is that way?
What is that?
She said, we have a magic way to do this.
Yeah.
What's the magic?
Maybe I'm getting into the proprietary things here for the Riverbed solution. But
The mics.
sure.
Okay, never mind then.
But I'm just curious, the end result is two TCP segments, right? And the Steelhead is just merging the two segments,
Yes.
two sessions?
Yes.
Okay.
Yeah. Any more questions?
Yeah, but apparently you're not going to give us the answers, so.
So maybe I can talk a little bit into that.
Okay.
This
Yeah,
is
it's okay.
Okay, yeah.
so. What we have done is in an SSL session, let's say typically when you have a client talking to a server, there is a phase which is the key negotiation phase, where the key is negotiated between the client and the server. And that is the phase that uses this asymmetric keys that are part of the SSL certificates in the private, the RSA-based keys. But once the key is negotiated, it switches to a data transfer phase, where it uses a symmetric key for encrypting and decrypting traffic. And that key that was created at the end of the key negotiation phase, so at the end of the key negotiation phase, there is a key that both of them come up with. And this key is what is used to encrypt the data that is sent back and forth. Now this key is useful only for that session. This is not the one that is the private key that the server may use. The private key is used in this part. So that is our realization. So once we identified that, we said, okay, your data center version of our Riverbed solution acts like your server, the man in the middle. But once you compute the key, you send that securely over to your other counterpart that may be closer to your client, to decrypt the traffic that's coming in. Does that make sense?
Yes, thank you.
Yeah. So that is how we do it.
Okay. Thank you.
All right. Any more questions? Okay. So now let me get into the topic of video. Now, I'm back to illustrating our strength in applications, and to highlight this application, I'm choosing to talk about video. And video, as you know, is a very popular application, and it is, as Josh alluded to it, it is one of the reasons why the bandwidth demand has been going up. So definitely video is something that is on the minds of several enterprise network administrators. So it consumes a lot of bandwidth, and it is also sensitive to jitter and delays and such. So now in our minds, enterprise video is typically of two kinds. One is live video. A live video could be a CEO doing an all-hands presentation to all the employees in the company. A live, maybe a recreational video could be there is a event happening, like maybe a sports event that is being broadcast to all the users watching that live. On the other hand, we also have this on-demand video. Now let me talk about what we do for the live video. Now in the case of live video, let me point out to some of the history here. So there used to be all these media streaming protocols back in the 90s, which are all based on UDP, the RTSP and RTMP and such. And then in the 2000s, the media streaming protocols evolved into progressive download, which was typically over HTTP. But the modern way of doing this is what is called as the adaptive streaming protocols. And these adaptive streaming protocols, for example, our iOS devices do what is called as Apple HTTP live streaming, Apple HLS, and there is Adobe HDS, and Microsoft has a version called Silverlight, Microsoft Smooth Streaming. So all of these are called the adaptive streaming protocols. And these adaptive streaming protocols, they are up here. They ride over HTTP. In most cases, they might even be encrypted. And this is the protocol stack for those adaptive streaming protocols. And for those adaptive streaming protocols, Riverbed products do understand, Riverbed Steelhead understands these protocols. And one thing that we do, for example, if I could highlight here back to the CEO broadcast use case, let's say you have a CEO in your headquarters doing the broadcast to all the employees. And let's say you have users in San Francisco office, there are users in, let's say, New York office. If all of them are watching this live video stream, they might be fetching a single stream for each one of them. Now, what we do on the Steelhead is that we understand these protocols. We understand that these users are watching the same video stream at the same point in time. So we actually fetch one stream and then split it to all the users in that branch. Now this technique of stream splitting saves on this network bandwidth for this video that's being used, as well as it gives better user experience for the end user. So this is our strategy for the live video stream splitting. And now this is possible only because we are able to get this far into this application, to be able to understand what this application does. Now let me talk about on-demand video. And here let me focus on one particular use case. This is the viral video use case. Okay, what we normally call as viral video use case, where a friend sends an email to a bunch of friends and everyone clicks at the same time and all of them hit YouTube, for example, and fetch the same video. So now in this case, let me go into a little bit of detail into YouTube and what we do. Again, going back to what we do by understanding the application and understanding at this layer. So let me draw a picture here. Let's say you have a user, and there's a YouTube data center somewhere. Let's say I want to watch a particular video. So let's say there's an ID for that video. Now, this YouTube, by the way, is SSL now. It's all encrypted. So we do get up to here only because we can decrypt that YouTube traffic and all the requests, and we watch all of that. So now, when this user goes to watch this, YouTube, the Google data centers, there are Google data centers all over the world. And there are these very complex clustering and load balancing algorithms that Google uses that redirect you to multiple data centers, and maybe ultimately, even within a data center, because of all the clustering algorithms, there may be some server that will finally provide you the video content that you need to watch the video. Now, had it been for a traditional web cache or a web proxy, for example, you would have typically had a key value kind of mapping in your cache, where your URI would have been your key and your object would have been the data. This kind of traditional proxying and caching mechanism would not work in this world. In this world, here, first of all, these requests and responses, these are redirection responses. Your original request did not even get the video. You had to go through multiple steps, and finally, you get the video from somebody else. Now, you have to really track all of this to really understand what is happening in this application, to know that this is the video content. And that is the power of understanding the application. And that's what we have in our Steelheads. Okay? So now I'm going to pause here and let Crystal show you a demo of what we can do for YouTube.
Hi everyone, my name is Crystal Lee. I am a technical marketing engineer in Riverbed Steelhead team. So let me close this and bring my own. Where's the desktop? Okay, here you go. The demo mode. To do the slideshow here. Okay. So today I'm going to talk about a web proxy demo on the YouTube video, the YouTube caching. So this is my demo topology. I have one client that's sitting in the branch office, along with many other clients. So all the clients can get into the internet to watch the YouTube video through this Steelhead in-path interface. And because for the web proxy, we need the Steel Central controller to configure it. So we have this SCC somewhere in the headquarters. So say one day someone sent out an email to share a YouTube link. And I'm not the early person, so I'm not the first one who opened the link. So say before me, there are 10 people already watched the video. So by the time I am watching the video, hopefully, most likely, it's already been cached in the steelhead. And I can probably, leverage that. Now, let me go to my remote desktop to go to my client. And meanwhile, let me open up a web browser. Chrome is what I usually use. Okay. So this is my client user admin. I think I'm entering it wrong. Okay, so this is my steelhead. Let me pull it side by side. So I'm going to go to the current connection for the real-time monitoring of the current connection. So as you can see, I can filter it with the application type. So I type YouTube here and do an update. So now, because nothing's going on, so we don't see any connections. Okay, back to my clients. Good, I got an email from someone called Crystal, and I click the video. Now we go back to the steelhead and click update the connection again. So we see a bunch of connections are open. So it's pretty normal when we see a bunch of connections are open when we open up a web page. Some are for ads, some are for comments or related video and so on. But what we want to pay attention is something like this, which carrying the video traffic. So the status on the LAN and WAN column actually means the throughput on the LAN side and the WAN side of the steelhead. So basically, this connection means because of the web proxy, the user is getting this video content from the steelhead cache via its LAN side instead of go all the way to the internet. So usually 3 to 4 minutes video with good quality can be 10 meg to 20 meg. So say if 100 person after me download this, watching the same video, so we're looking at about 1 gig to 2 gig WAN bandwidth saving here. So before I move on, I actually want to go to my SCC to show the dashboard. So here, it actually shows the top applications that the steelheads that is managed by the CC sees all the traffic. So in my case, the YouTube is the top application that's being optimized in my environment. And on the SCC, there is another page that you can see an overview, overall view of how the web proxy can help you on your IT saving is this cache hit ratio. So basically, this means the average percentage that the users get the web objects from the cache versus overall over the WAN. So, and you can see it's past 2 weeks. So it's a long-term view of what's going on there. So that's it from me. I'll pass it to Ashish again.
Okay, thank you, Crystal. Any questions? The demo or the YouTube part?
I can keep the window open.
Oh. Sorry. Any questions?
Yeah, I'm just curious, how does the appliance determine which content exactly to cache? Is it based on number of requests within a certain time frame for that video, or is it different criteria?
So, like I said, when I said we understand the application, we look at the requests that are being made at the HTTP layer, and there are these query parameters in that URI itself that determine that this user is trying to watch a YouTube video. So we understand all of that detail. And we also know that this content is served from Google video servers. So we know that these host names, that these are coming from Google video servers, even with all the clustering algorithms that might happen. So that is the intelligence that helps us to identify that this is actually video. We look at the type of the responses as well. It'll tell us that it is video content. So all of these put together help us answer that question.
And one point I want to make is the YouTube is HTTPS web object, so which means we can cache the HTTP.
Yeah, that's a good point. It's HTTPS.
So do you cache all YouTube videos?
Well, I mean, if the feature is turned on and if the steelhead is configured, yes. But we do have a size limit on the box, so we do wrap around after that.
So are you effectively, with the adaptive rates that get sent to clients, right, that first person who comes through at a certain resolution, and presumably you might have to cache multiple resolutions if people choose different qualities, right? But that first person coming through doesn't necessarily get a flat bit rate. I'm not sure if the bit rate's adjusted on the fly, or if it's just, here's the quality, we'll throw it to you this fast if we can, otherwise we slow down. So do you end up with whatever experience the first person had, that's what everyone else gets?
So,
or is it kind of smarter than that? And
no, we do understand the differences, and let's say one user might be coming from their smartphone, another user might be using a desktop, and maybe using a different browser. So there are differences, and these are actually some of the parameters that show up in that request that goes to the server. So we understand that these are different users, and we try not to serve one content that was designed for, let's say, a smartphone user to a desktop user, or a user at one resolution to another user at a different resolution. So we try to have a match, and only then we can.
So you may end up being forced to cache 10 copies of the same video for different user agents at different resolutions.
Yeah, we could.
Because they're different, right?
We could, yes.
Okay.
Yeah.
So we should definitely move on if we're going to get to some of the platform stuff. So for this next piece, Shashi is going to talk about that last piece, which is why is this web proxy interesting and important from an architectural standpoint as it relates to hybrid WAN path selection?
Yeah.
Right. And so there's really kind of an architectural discussion about why this was important than just caching YouTube videos.
So let me go back to this picture again, and I'm now trying to focus on the TCP part and why being a transparent TCP proxy is a foundation for us to build to address some of the SD-WAN use cases. Let me use Scott's picture that he has drawn here to illustrate one use case. So let's say you have users in a branch trying to go to Office 365. Let's say you have option 1 that would take you through the data center and out to Office 365. You have an option 2 that you could go directly out from the branch itself to the the SaaS service here. Now, the decision of what to do, whether to backhaul to the data center or to send directly to the branch, that decision is something that has to be made at this point in the branch. Now, let me walk you through a scenario here. So, to be able to make that decision, you need to identify that this particular flow, that this particular connection that has come in belongs to this particular SaaS application. And this is an application-driven policy, for example. So if I can go back to a lifetime of a connection here, let me go back to a client and a server, a time diagram. Time is increasing downwards. So typically you start with, let's say, a TCP handshake. You have a SYN, and you have a SYN-ACK, and then an ACK, and then finally you have data that comes in. So most solutions that do the deep packet inspection need to go further down to actually be able to identify the application. At this first SYN that you get, all you have is information about IP addresses, destination IP addresses, and port numbers. So that information, in most cases, is not sufficient. Primarily because IP addresses, for example, for these SaaS vendors is something that evolves over time. Microsoft is opening new data centers every month. So this IP address range changes over time. And one IP address could actually serve multiple applications too. Think about a content delivery network. So IP address information at that network layer is not sufficient. You really need to go down to the data to actually figure out that this connection belongs to this application. So the point I'm making here is that identifying which application that this connection belongs to takes time in the lifetime of a connection. Now keep that in mind. And when you keep that in mind, and let's say if I have a connection that came in, let's say a TCP SYN that came into our, from a user in this branch, and if I backhaul that to the data center and sent out, I would likely be using a public IP address of this location at the data center location talking to that server. Now after certain back and forth transactions, if I detect that this is an application that I should actually send directly to the internet, it's already too late because this server thinks that you are coming from here. And you can't simply transfer that traffic over here because you would be breaking this connection. The only option you have is to reset that connection and start a new one. And when you do that, clients will see that there is a disruption on their end too. Okay? So what we do, our solution here is to actually become a proxy, a TCP proxy. And once we become a TCP proxy, the client is talking to us first. And once they talk to us first, and we find out what the application is, and then make the connection out, whether this way or that way. So this ties back to a real SD-WAN use case that customers want to be able to direct the SaaS traffic directly out to the internet as opposed to backhaul. So I hope that makes sense.
So you're getting, and I understand TCP proxying, but effectively you're looking at really the first packet of data being sent, because you can't go beyond that because they're often expecting a response by that point. But in that first packet, if it's an HTTP request, sure, you can see a header. If it's something else, I guess you often get lucky. There's some kind of initialization message. There's something that gives you a clue as to what it is.
No, first of all, since this is local, if let's say if it's the first response that maybe something that I can serve locally, I could perhaps even serve locally and even go further in that transactions with the client if I need to figure out what that application is. So there's not much latency here in this in the branch itself. But let's say if I can't figure out what that application is at that point, because I am a TCP proxy, I still hold my connection with the client. I can change the connection that I have on my back end without disrupting the client.
Yeah, I'm just saying that you have to have already initiated that back end through the correct path, right, in order for that to be of any use. So if I'm trying to authenticate to something, there's no point having me authenticate through the proxy the wrong way and then going, oh, I'll build it the other way now, unless you're going to remember all of that authentication information and do it again through the second path and the second NAT, right? Or straight out to the internet, right?
You're right.
So
Yeah, you're right. Yeah.